Thank you very much. What a lively crowd. It's great that you all came out for this evening. Hope that you enjoy the program. Tonight it's all about drones, applications, investment, and opportunities. Before we bring up our amazing group of speakers, a few words about the Churchill Club. We have been operating in the Bay Area now for almost 30 years as an independent forum, very interested in innovation, economic growth, and societal benefit. We put on about 30 of these programs each year on a variety of tech-related topics and leadership, etc. And we hope that you will get to know us better if you don't already. Next up, next week, we have AI startups and also the CEO of BlackBerry, John Cheng. And then on September 24th, we have a program that is annual called The Churchills. And two of the segments at that event will be Andy Grove, the legendary former CEO of Intel, and Pixar, with the head of that organization, Pixar Animation Studios, talking about collaboration and mentorship. So I hope that you'll be there for those amazing opportunities. Certainly want to thank Accenture, without whose help this program would not be happening right now. In particular, Robin Murdoch, Julie Rosendahl, and John Walsh. Thank you, Accenture. If you tweet tonight, please use the hashtag Churchill Club, and you will find other Twitter codes in your printed programs. So now I want to turn our attention to the topic at hand, and I'm going to call up our speakers, starting with our moderator, Robin Murdoch. Next, Adam Bry, Skydio. Hi, Robin. Dan Burton, Dronebase. Eric Cheng, returning to the stage from DJI. Dave Merrill, 3D Robotics. And Christian Sanz from Skycatch. Robin, it's all yours.
Thank you. Thanks very much, Karen. So our discussion this evening's on drone technology, and obviously we've all seen so much development over the last year in the space. So it's a fascinating topic. You'll notice that we're saying it's civilian drones, so we're steering clear of military. We're just going to talk about commercial and consumer. And we ran a similar panel about a year ago, and we were fortunate enough to have Christian and Eric on that panel. And the change in the last year has been pretty remarkable. You'll have seen the footage from Eric from Good Morning America when they shot live footage of lava flows in Iceland. Huge development in terms of investment. In fact, every single one of our panelist companies has had new investment in the past year, with Christian actually announcing today his Series B. So congratulations on your Series B. And so we've got an amazing panel, and I'd like to kick off with you introducing yourself. So Adam, why don't you go first?
Yes, I'm co-founder and CEO at Skydio. We build a computer vision navigation system for drones to hopefully stop them from running into things. Before that, I was a co-founder of Project Wing at Google X.
I'm Dan Burton. I'm the co-founder and CEO of Dronebase. We provide on-demand drone services, so enterprise customers just push a button and get imagery, video, maps, and analysis. And we've built a kind of community of pilots all over the US and all over the world that go and do that. So just a variable cost way for you to engage with this technology.
I'm Eric Cheng. I'm Director of Aerial Imaging at DJI and the GM of the local office here in San Francisco. DJI is the largest drone manufacturer in the world, and we make the Phantom, which is this little white thing you see here.
Dave Merrill. I'm the VP of Enabling Technology at 3D Robotics. 3D Robotics started out as a supplier for DIY kits and parts, and then recently has moved into consumer products. And we just launched Solo, the black drone up here in the front. And we are the largest American drone manufacturer. And my job is to seek out new technology for future products at 3DR.
My name is Sanz. I'm the CEO and co-founder of Skycatch. We build software, drones, and we have services, and we operate in the commercial space. We work with companies like Komatsu, Bechtel, Clayco, and we mainly focus on providing intelligence to optimize these big markets.
Great. So I'd like to kick off with a question for each of you, and we'll start with Christian. Incredible change and momentum in the space over the last year. You've all been at the center of this change. Christian, what surprised you about what's happened in the past year?
I think the biggest surprise has been how quickly the market has matured. We didn't see some of these companies a year ago. We're terrified to even be associated with drones. And today they're filing exemptions, they're writing about it on blog posts, and I mean companies like Bechtel. A lot of these companies are public and they have shareholders, so they're very worried about perception. Today, every single company out there, Fortune 500, they're thinking about their drone strategy. So that's one of the biggest changes that we've seen, and we've had to change the way we structure our company and our services to adapt to that growth.
Great. Dave?
I think the thing that has surprised me is just the enormous growth in the consumer drone space. Just there are so many people getting inspired by the videos that they see, like videos on YouTube showing amazing views of the world from above that just people couldn't have seen before. And I think that is driving this enormous demand for the product, because once you see a video like that, if you have any interest in photography, you want to go do that yourself. And I think that is just, it's growing faster than I even thought it would a year ago.
Great.
Yeah, I guess I'm not as surprised about very much because I think a year ago we were already on this crazy exponential curve in technology. So it feels like we've hopped on to just rapid growth, at least technologically. I think what I've been surprised by is how long it's taking for the regulatory environment to change, to kind of adapt to all of the things that we're doing here. So it's great that the exemption process is now, we've given exemptions FAA to over 1,000 groups out there. But of course, what we really want is a rule that we can all use to sort of grow.
I think we've been surprised just by how systems that seemed like consumer systems are actually solving enterprise-grade use cases, not just simple image and video, but also where you're deep technical things where you need to get to a tolerance of centimeters or less. So we've just been just like your enterprise phone is an iPhone and your enterprise computer is a MacBook. It seems to us that these consumer systems are actually quite powerful, and that unlocks kind of a very distributed network model where these services can happen quickly for low cost.
Right. Adam?
Yeah, I think I'd kind of echo what Dave said. I think that a year ago there was a lot of fear within the industry, it seemed, that the public reaction was going to be sort of more worried about privacy and a lot of the negative things. And I think that overwhelmingly it seems like people are taking sort of a curious, open posture to what can this technology do for me, which I think is really, really positive.
Great. Maybe next question for both Eric and Dave. Both of your companies obviously focused in the consumer space. As drones are becoming more mainstream, lots more people are using them. How is usage evolving in the consumer space? What's working, what's not working? Maybe Eric, do you want to?
Well, I think in the creative space / hobbyist space, we've seen just obviously an absolute explosion. And I think it's one of the big differences now is that it's pretty normal to see something, a consumer-grade drone flying. And people, of course, have differing reactions to that when they see it. But I think everyone now, if you ask them, they probably have a reaction, whereas before they might have said, I've never seen one of those. And so, of course, I think if you just do a YouTube search, I think I asked people to do this last year, too, you'll see the incredible variety of things people are doing. I mean, this volcano video was maybe at one extreme end, but I think a lot of people haven't even seen pictures of their houses. And the other thing is that we're seeing this huge crossover into commercial usage. So more and more, I think people are trying to figure out how they can leverage this fairly inexpensive tech to do things that could save a lot of money, mostly, but also to do things more safely.
Right.
Yeah, I would, to follow on that, we sort of started as a company by building a Swiss Army knife in our autopilot. That was it's called Pixoc. It's this open source autopilot. It's really widely deployed. There's this developer community around the world of people that contribute code to it without even being paid. And so that was already driving all this commercial use and hobbyist use before. It was kind of the way that anybody who wanted to put together a somewhat custom system would do it if they needed to do it at low cost. But what seems to be working now is like having this really easy-to-use system wrapped around that powerful autopilot that's basically the brainstem is enabling all this creativity. So the kind of videos you mentioned, Eric, I've seen just in the past week, all these people are doing light painting now that they've unboxed their product, and they set a camera on the ground with a long exposure and then fly the Solo around for a while and get these amazing swirls in the air. So, people are, it's like there's this advancing frontier of creativity, which I'm sure photography in general has this, right? It's like you don't want to do something somebody else did. And so people keep on exploring to find out what you can do next.
So maybe just staying on sort of the consumer space, we've obviously seen lots of media attention on incidents with drones over the last year. From an industry perspective, how do you help amateurs use drones safely and legally? So what are your companies doing around those dimensions? Maybe, Dave, start with you.
Sure. So education first. So we make training videos that we really encourage people to watch them before they ever put their drone in the air. There's a simulator that they can play to fly a simulated drone before they ever spin up the props on the real one. And then, our approach to designing the interface on the app is to put these small interstitial explanations ahead of each move that's not just the basic using the sticks to fly somewhere. And I think that's the first step, is really to just get the drone operator to understand the mental model of what's going to happen when I do this thing to it. Because the most common accident is somebody pushes the stick or presses a button and they didn't know what to expect, at least with the kind of earlier generation of RC drones, and then it does something they didn't expect and they don't know how to recover. So I think that's the biggest thing that we're doing, and we got to all keep doing, is make it harder and harder to do something you don't expect.
Eric, anything?
Yeah. I think right now we're in a sort of strange stage in consumer drones, in that we're piloting manually. The number of tools that are available for people to not fly manually are still fairly primitive. I think when we start talking to Adam, you'll see, I think, a lot of more excitement in this space about to happen. But I think for us there are two things, and one is preventing people from doing things on accident. So if you are unclear where you should fly, or you've taken this thing out for the first time, there need to be some limitations to the firmware, at least out of the box. So these would be things like altitude limits, which are built into the platform, and perhaps some sort of geofencing, like not flying near airports. And these aren't meant to prevent bad actors from doing things, because if someone wants to do something, they're not going to be limited by what we're doing in a consumer product, for example. But the other, I think, is while we have the attention of people using basically smart devices as the interface to drones, it's a great place to be able to message them in real time as they're using the product.
Right. Now, Adam, you're looking at some really interesting technologies around collision avoidance, etc. How do you see the technology enabling consumers to stop having accidents and fly more effectively?
Yeah, well, I think the first thing to know is a pretty typical first user experience of these things is you take it out of the box and crash it, and it's still an awesome product. People love it. And I think that's kind of testament to the power of the platform, because if you can get over that, you can do really incredible things with it. So the way we think about it, I think that onboard awareness and intelligence and being aware of your surroundings is kind of the gateway to most autonomy things that you want to do. It's hard to imagine an autonomous device acting on its own without being aware of its surroundings. So a lot of people sort of think of see and avoid or collision avoidance as just a problem that needs to get solved, and then we'll go on. I think that it's really, we see it as more than that. I think it's the gateway to just a huge runway of exciting things that you can do. And the paradigm shift that we're really interested in is sort of the notion of a trusted tool that you can put in the air and you can just count on it to get the video that you want, or you can count on it to get the data that your business needs. And I think we're starting to see signs that this is the way people want to use them. But it's difficult to do that with existing technology.
How big can maybe Dan? How big can the drone market be? We've heard. Is it going to be a limited scope, or is it going to be something where it's as common as the smartphone? What's your sense?
Yeah, I think it's a great question. I mean, I think for us or for commercial companies, I think if folks are doing something by a helicopter or airplane, just as almost a guarantee, you can do that better, faster, cheaper via drone. That's an easy conversation. The much bigger market is a new market where there's a process of education involved, a process of speaking with people who may have never used this or could never afford aerial anything, whether that's a satellite, airplane, or helicopter. I feel like the best where we see it going, or where we feel like it's going, is almost more like a server, if you will. I don't think every single person will need a drone. In the commercial space, it's almost more like a server. I think today it still feels like a skilled pilot needs to go do the work. I think there'll be some period where companies feel like it's so easy, I can do this, and then there'll be a period where companies say, why the heck am I doing this? Because you probably just need to fly once a week or maybe once a month for 15 minutes, so your asset utilization's sub 1%. I mean, we tend to think of this as more like a server going eventually to like Amazon Web Services or AWS, where you literally just would pay for the amount that you would use the system.
Right. So you talked about commercial space. Christian, let's there's been so much development with your company over the last year. What are the examples that are really thriving in the commercial space? What's working? Where are the spaces where you're seeing the most demand, and why?
I think there's a variety of different spaces in the commercial side that are now experimenting with drone data. And it goes beyond the stuff that people write about. It's beyond construction and beyond mining. I think even companies that are not doing drones or technology are getting into drones today. Like Cisco, there's consulting firms that are getting into the drone space and on the service side. So I think that there isn't enough data today to see exactly which direction or how big this is going to be. But we've seen a rapid growth and maturity in terms of the interest in companies and as far as investing in teams and building teams and putting money and budget into discovering what exactly can we do with this and what teams can we optimize with this new data set. I think that at 6 months to a year, we've learned a lot. Like last year in December, October, we were approached by Komatsu, and the stuff they were asking for wasn't on anybody's pitch deck. Nobody really suspected that a company was going to completely automate bulldozers. That wasn't part of our roadmap. So who is the next Komatsu next year, right? So these are things that, same thing, we have companies coming to us for plane inspection, detecting patterns on airplanes after a thunderstorm to see if they find a lightning strike on it. And
I have to ask, you said bulldozers, so how is the drone working with the bulldozer?
So the bulldozers is our drones are fully autonomous. They go out in the field and they take off, they land, the data gets processed, gets to the cloud, the bulldozer then pulls the data from the cloud. We run it, before we do that, we run it through this thing called ground return, which our own algorithms, we remove all the stuff that are not the terrain. And then they do a comparison between where it needs to be and where it is today. And then the bulldozer kind of starts following a track of where to cut the dirt. As soon as it's done, it sends an array of GPS coordinates. Then we go back to our drone. We say, okay, go back and cover that small area. Land again and send that to cover that small spot, send that to the cloud, and goes back up. It's really just giving these machines eyes and visibility. This was never done before, and the reason why we were doing this with Komatsu is because in Komatsu, in Japan, the population is mostly younger people, and it was really hard for them to find drivers to drive these bulldozers. So a lot of their clients, they have 45,000 active job sites every year. A lot of their customers are complaining about the fact that they couldn't hire skilled drivers to drive these things. So Komatsu decided to completely automate it. And also the speed in which you're able to drive these machines changes how much money you can make from that project. So the faster you can drive it, the more money you can make from the project owner. So there are a lot of combinations that gave birth to this demand on their end. And now we're seeing other companies that are mirroring the same initiative that Komatsu started this at the beginning of the year.
When we were speaking earlier, you mentioned huge productivity improvements, an order of magnitude more than I was thinking. Can you talk about that?
So yeah, you were asking me about what do you think about the future and when it comes to the commercial space. What I think and what we see is 2, 3 years, 5 years from now, there's going to be massive improvement in productivity across a variety of different use cases, mainly because now they'll have access to information they can actually act on immediately. So the speed in which they were able to act on things before was much larger. Now they'll be able to make decisions very quickly. And not only that, you'll be able to get information you never really had before. So I'm thinking across all of these different industries, you'll have 30 to 40% speed improvement across the board. So if you think of living in a world where construction is 60% faster or 70% faster, what does that mean? Like for the developing world or for building a house or restructuring a building, things are just going to change completely. And now you have Komatsu starting a whole new initiative of making this fully autonomous. They want to automate the entire process of building, and this is the birth of it. Right. And it's going to happen. 30 years from now, we're going to have the systems and machines to be able to fully automate the process of building construction.
So Dan, your company still going after the commercial space, but in a very different way. Where are you seeing demand now?
Yeah, I mean, so, and obviously really interesting thoughts from Christian there. So, again, I think that typically things that people, just easy to orient around, things that people are using a plane or airplane to do typically, or a helicopter to do. And so, in some cases, people are paying an airplane $120,000 for 4 surveys of their site a year. And so with these systems, again, you can do that for a 20th of the price. So you can then do it, you can do it 4 times often, you can do it 10 times often and still not break even. So there are some, I think, like kind of core products around like mapping and surveying. And then oftentimes it's just simply image and video. People still find a lot of value from that. In fact, like a lot of our conversations start around that, and then it just is a process of education to get people oriented around mapping and surveying.
And you were saying that your many of your suppliers, the people who are flying, are using consumer-grade equipment to pull off what they're wanting to do.
Sure. I mean, again, like we're going to like oil and gas construction sites doing 200 acres in 30 minutes with an Inspire One. Fully autonomously to centimeters accuracy. And so again, like a year ago, that was impossible. But now, like that whole solution costs under $2,500. Right. And so, like the incremental cost of doing more work it's like you just recharge a battery and wipe data off an SD card. And so for our suppliers, they literally just want volume of work.
So DJI consumer-grade equipment being used commercially. Now, Christian, I understand you're starting to look at that as well.
Yeah, we're investing in developing software on top of platforms that have very reliable software. The first one we chose was the DJI platform. We believe that our main focus is providing services to the client and with the objective of getting them subscribed to use our intelligence engine, our data processing. In our software side, on our hardware side, we want to entertain other platforms so that if you have a DJI, you can do the same things that we've optimized with our software. Basically, you can do it with any of these platforms. If you want to do ground following, if you want to do ground return, if you want to do anything interesting in the commercial world, you'll be able to do that with our software on top of the running on top of the platform.
Great. Now, one of the questions I want to ask, and it's about Amazon. None of you are from Amazon, but Adam, I want to ask you because you've got the heritage with Google with the Wing program. There's been lots of market hype around around prime air, and it's still hype. We haven't seen the product, but how far are we away technically from being able to do delivery with drones, sort of logistics with drones?
Yeah, so I think that delivery ties together a lot of really hard problems. Like, it forces the mechanical reliability has to be nearly perfect. The navigation system has to be basically perfect. All the flight control, everything about the operation has to work perfectly. And the consequences if you get it wrong are really severe, because if you're carrying a 5-kilogram package, the drone probably weighs 20 or 25 kilograms. So I think that it will happen, and I have no information on what Amazon is actually up to.
Let's talk generically.
But I think that it's going to hit all those thresholds and to hit them in a way that's certifiable and makes people comfortable, I think is quite a high bar. And I think one of our perspectives on this, I think that it's likely that the technology that's developed on these kinds of systems, where the stakes are much lower but there's still a lot of value to be provided, will kind of trickle over and enable a lot of these higher end use cases.
Got it. Maybe Dan, where's the value going to come in the market? We've seen amazing development over the last year, where for just around $1,000 you can get a drone that would have cost you $4,000 a year ago. Where's the money going to be in the commercial space? I think it's clear in the consumer space, selling devices is a great opportunity, but you're obviously going after a very different market. So, question for you, and then we'll ask Christian the same.
Yeah, so we may have a little different take on it. I think there's a lot of value to be had, and so, for example, with DJI is a joint investing fund with Excel called Sky Fund, and our company Dronebase was the first investment from that fund. And so, DJI, although it's very large, obviously, it's actually quite focused on what they do, and they roll out incredible products almost every 6 months. I think others are building great pieces of kind of deep software infrastructure that are doing autopilots and some of the really high horsepower mapping infrastructure. And then we find a lot of value just in the services space, just purely in the kind of marketing, sales, payments, trust, processing, and execution piece. So we feel very good just in that layer, which may even seem a little thin to folks, that there's a very valuable company to be had there. So we've found success just kind of working with partnerships and letting people get really good at their kind of horizontal piece of the stack.
Right.
What we've learned from our clients, our clients forced us into providing services that we never predicted we would offer. We today do R&D, discovery, integration. We actually send engineers to integrate into their workflow. We do support, we do training. All of those things we didn't think about when I started Skycatch. These are things that are essential when working with these big companies. So they're absolutely going to become a big component of working with these massive industries. And we're already seeing construction firms providing or morphing into these data service provider or training component, working with competitors in the same industry, providing this new area. The other side is what we're really interested in, which is software, ground return, 3D models, data processing. A year from now, the expectations for data processing are going to go way up. People are going to expect data processing to happen almost instantly. They're going to want to see the data in 30 minutes or less. It's already happening. We're getting demand from our Komatsu partners. It needs to happen faster. It needs to happen fast. That's forcing us, and we're seeing that across multiple different industries. And obviously the autopilot and the machine itself. But I think the real value and the real opportunity is in the software.
Okay. Eric, a question on sort of the professional side of media. We've seen lots of new use cases, your one being a great case in point in Iceland. How does the technology differ in the professional media space? Is it all getting consumerized? What's different about the technology that you're seeing being used? And maybe for prosumer, but also professional movie making, those kind of things.
I guess it depends what kind of media you're talking about. I think the videos that most of us see, which are aerial videos, are taken with consumer-grade products. And for example, on TV sets, we used to see big custom rigs, hexacopters, octopters holding SLRs and other things that were, good enough for TV, maybe not good enough for most uses in filmmaking. But we're seeing those systems being used less and less because they're a pain to use. Typically you need a crew, and there's exactly one because it's a custom build. And with these, if something happens, you can order another one on Amazon, and it will show up the next day. And the image quality is good and is getting better. So I think what's going to happen is that sort of this medium size, Inspire size quadcopter will sort of inherit better and better camera tech over time, or will develop it. And a lot of those custom rigs are just going to go away. I mean, we talked about this, multi-$1,000 quadcopters a year ago costing $1,000 now. But the real truth is that you cannot build what you can buy for $1,000 now. As a hobbyist at home or in the DIY space, you just can't build it for any amount of money because the integration has gotten so good that something even like a $1,000 Phantom is now starting to feel like a camera that's flying, and you're controlling the camera, using very familiar control systems, like the same sorts of buttons and dials that you would find on a normal camera, instead of operating it via a touchscreen, for example, which doesn't have the right kind of feedback for good photography. In the very high end, I think we're still going to see people flying big cameras if they have specialized needs, like very, very good resolution or image quality or 1,000 frames a second. I think we're always going to see that, but we'll see a lot more in the integrated camera space going forward, including perhaps drones with interchangeable lenses where you buy the drone and then you just choose a lens for it.
Dave, I know that your company's obviously 3D Robotics has some of the most popular control systems. How are you seeing it in the professional media space? How's that evolving?
Well, I think the trend that Eric pointed out is true. There are fewer and fewer reasons to use big, bulky, difficult-to-use drones anymore when you can put such good cameras on small ones. I mean, with Solo, we are placing the first bet here on GoPro because GoPro cameras are just so ubiquitous. I don't have the number, but I think GoPro sells something like 1 million cameras per month. And they're very good now. They've evolved a lot in quality. And so I think the camera's getting better and better is this kind of technological inevitability that's just a force in the market right now. So they're going to get good and small. But actually, to me, the challenge that I get really excited about is this usability question. As I have a computer science and human-computer interaction background. And so the challenge that we face is really like human-robot interaction. Like you have an idea in your head, and you want that drone to go do something in the sky. And how do you do it? Like so that's basically the challenge that our design team has, is what's the most natural, intuitive, straightforward way to allow that thought in somebody's brain to become a trajectory for a copter and a camera. Yeah. And so I think in my mind, that's really where the space differentiates in the future in consumer. It's like these different philosophies for how to control the system or just race to the most usable and to stay ahead with the most usable system.
So let's get stuck into the underlying technology of these things. And maybe, Dave, let's just stay on that point. One of the things we've seen, a whole bunch of Kickstarter projects that have these great videos that show someone throwing a drone into the air and then miraculously it follows them past trees. And where are we relative to Follow Me? Is Follow Me...
Yeah. I love that video. So many people, when they hear that I work in drones, ask me about that video. I think more people have seen that than know about DJI or 3DR or anything else. That's really hard. That kind of like the earlier comment that Adam made about delivery, just throwing a drone in the air and having it follow you down the slopes while you snowboard, it requires a convergence of a bunch of things to happen just right. Following a person has been possible for a long time. We've done it with GPS in the person's phone for years now. So you've been able to walk out to a big wide open space, like a beach or a soccer field, put the drone up in the air, and then walk around with your phone, and it follows you just fine. But the trick is, how does it know about the environment, right? So to your point earlier, like it'll hit a tree if you try this going down a mountain through, and you're snowboarding through the trees. And so that kind of Follow Me technology is this kind of shared dream that everybody who's even thought about drones has. And I think we're going to get there, and it will be pretty soon, but it's harder than everybody thinks when they first imagine it.
So Adam, walk us through how on earth do you pull off follow me? Like, what are all the so you mentioned there's lots of things that need to be overcome. You know, what are those things? What are those technical challenges? And where are we with those challenges?
I think first off, I'd agree. I mean, I think it's an awesome concept. It's essentially like a professional cinematographer in your pocket, right, that does whatever you want it to do. And I mean, I agree with what was said before. I think that there's just kind of like gating problems there. Like, you can do it in a wide open space using GPS, but it's very difficult to explain to somebody like when GPS fails and why it fails and like why their drone isn't doing what they expect it to do.
When does GPS fail?
So it's hard to predict. I mean, I think a general rule of thumb is if you're above the tallest thing around you, you're probably okay. As soon as you come below that, it's harder to know for sure. And as you get closer to buildings and structures, you can get multipath errors and other kinds of things. So I think that we will get there, and I think that the technology to do that is stuff that we're super interested in. I think that sort of computer vision navigation, having an understanding of the 3D structure of the world around you, having an understanding of like where the person is and how they're moving, and being able to like couple all that together into what you actually want the drone to do. Like from a software standpoint, like those are kind of the moving pieces.
Okay, so I asked you a dumb question earlier, and I'm going to ask it on stage. So my iPhone's got the IMU, the thing that knows that it's going up, it's going down, left, right. Why doesn't that provide enough positional data to tell the drone where it is?
Yeah, so the analogy there is like imagine if you got into a car that wasn't moving and closed your eyes, and then somebody else started driving it around, and when they were done, they asked you to like estimate your position relative to where you started. Like you would know the bulk features, you would know that you like accelerated and you turned, but you would really have like no idea how far you had actually traveled. And the difficulty is that the IMU, the inertial measurement unit in your phone, it tells you your acceleration, but then you have to extrapolate that to velocity and then to position. And no matter how good the sensor is, those things just drift pretty quickly over time. So the practical reality with sensors today is like after a couple of seconds, like you could be on the other side of the room, and after a minute, like you could be in China.
Right. That's problematic. Yeah. So talk to us about the kind of sensors that maybe Eric, the latest Phantom's got sonar. Can you talk through why that's an important technology to have on one of these devices?
Yeah, I would say that what you're talking about is the vision positioning system. So it's ultrasonic, and it's also optical flow. So that's for measuring kind of discrete distance to the ground, and also whether the aircraft is moving in any lateral direction. Another product is called Guidance, which is basically stereo cameras and ultrasonic in 5 directions, and that's in our commercial platform, the M100. So I think what we're seeing is that more and more sensors are being brought into drones because having one camera, which is typically used to capture imagery that you want to keep, is not enough for a given drone to know enough about its environment. First of all, nobody's really doing anything with that imaging data. I mean, some people are writing software using SDKs on both our platforms that use that live imaging data. But again, from one feed, it's hard to tell 3D information. You really need at least 2 cameras. So I think what we're going to see is, we'll see stereo cameras, ultrasonic, LiDAR, GPS, of course. They already have barometers, accelerometers, all sorts of things in them. So it's really a sensor fusion issue. It's really that you need as many sensors as possible to give the path planning algorithms enough information so that they can do something smart. So, we're already seeing a lot of this happening. And this is, I think if we did this in a year, we'll probably see really, really interesting devices that can navigate in a much more intelligent way.
So how does so you've got more and more sensors. That means you need to do a lot more of the compute on the device. You can't be using the cloud to tell you it's a tree, because you'll have hit the tree by the time the cloud's got the data. So what's the balance? Like, how's that balance going to work? Adam, what's going to be the role of the cloud? The cloud will play a role in it, but obviously for machine vision, you really need to do stuff locally.
Yeah, so I think drones are kind of one example of this. I think that we're entering like a really exciting new category of connected devices that do a lot on board and then also leverage the cloud. I mean, as you say, I think that anything that involves like the real-time control of the drone has to happen on board. But in a lot of ways, drones are essentially like data pipes back up to the cloud. Like that's how people are already using them. And there's some pretty natural things you can do to use that data to make the algorithms that are running on the device smarter. And so I think that as these systems become more ubiquitous, and especially systems with navigation built in, I think that there is going to be like an interesting link there where the systems are kind of continuously and automatically improving themselves based on data that's gathered from real use cases.
Right. Now, Christian, last year you were talking about your product where your drone flies from a carousel and the battery changes. How important in the commercial space is being able to have that persistent view or very regular view? You mentioned the companies you're working with needing those kind of scenarios.
Yeah, it's interesting because it kind of ties into the whole sensor innovation, the imaging, sense and avoid. One of the biggest challenges with some of these sensors is how much battery power is drawn from the drone. So that reduces the amount of time. I remember testing a sense and avoid board that was about a year and a half ago, and the amount of power that I was using would take the drone down from 20 minutes to 10 minutes to 8 minutes. Because there's a lot of image processing. And so the innovation in that space needs to be done based on optimizing your source code, optimizing how you create your 3D models and all of that. But innovation in the battery itself is still very stagnant. It hasn't evolved. Intel doesn't spend any money innovating the actual battery. They spend money turning off resources, right? That's how they get their stuff to last longer. And that's how a lot of us are having to apply sort of extending the life of the battery, right? So I think, the reason why we selected going in the direction of allowing for customers to be able to swap a battery or to charge on the fly was because these customers weren't really thinking about one site, weren't thinking about one place. As soon as you solve a problem for them, then they're thinking about how can you do the same across 5,000 places without me hiring 5,000 people. And that's the reason why we selected going in the direction of completely making this autonomous.
And is the hardware, moving to a point where you can just have multiple drones? You can, if you're needing to keep something aloft, you just have two that alternate. I mean, is the price dropping to the point where it's actually not a problem?
I mean, the drones and the sensors are becoming far more reliable. I think that the investment in miniaturizing all of these sensors that we're able to use today came from a huge investment from these companies who build smartphones, right? Now that we're having these companies build massive distribution of Phantoms, the sensor companies are becoming smarter and more efficient in building these sensors as well. I think that when it comes to on the commercial space, reliability is very important. I think that the concept of being able to be in the air for a lot longer or be able to take off and land 1,000 times without any issues, these are things that on the commercial space are very important.
Dave, different in the consumer space. I'm assuming, are flight times long enough?
It's not our highest priority to make flight times longer. If you're shooting video or photography, you can bring a backpack of a few batteries inside. So there are other problems that I'd rather solve first for the consumer use case than battery life. It'd be great, but it's not like a kind of hair on fire problem for consumers.
Right.
One other point about sensors is that up until now, the availability of sensors that made sense to put on consumer drones was mostly driven by price, right? Like there are great gyros and accelerometers that are very expensive that could, keep their eyes closed and remember where the car was for all day, but they're just too expensive or too heavy to put into a consumer drone. And so, we're largely drafting off of sensors that have some other use case in the market, like cell phones or industrial sensing or whatever it is. So I think as this field gets as this category gets bigger and bigger, we will start to command, new sensors being developed specifically for drones in a way that hasn't happened before. Like cameras are are all over the place and very cheap now because they get used by a lot of other products. But drones as a category is going to start to drive, I think, very specific new sensors.
And Dan, with your company, you're employing all of these contractors to shoot footage. How are you dealing with getting the data to your customers? How's that workflow happen?
Yeah, well, I mean, and essentially, like, as you could imagine, for us, the standardization of a few systems is profoundly helpful, because if you're going to go to 40 different work sites all over the country, then the customer gets literally the same output. So you're taking one of the hardest variables just out of the equation. You know what quality you'll get. You know when the pixelation will start to break up. You kind of know how many minutes you could fly. But I think, I'm sure everyone here would talk. I mean, every problem here is a tough problem. But yeah, data transfer, file sizes is definitely a nasty problem. Getting that to folks, getting it both uploaded and downloaded is a, that's a tough problem to solve. And but any tough problem that you approach is one you can provide value on. So that kind of speed of upload, speed of download, how fast people need it. Some people do want it right away. Others, a weekend is fine. Others, a week is fine. So it's been interesting for us to understand, getting that all over to folks, but doing it in like a repeatable, standardized, quick response time and affordable way, we think a lot about.
And that's something that you're dealing with, Christian, from you're pulling all this sensor data. How are you managing that workflow of getting it off the drone and making use of it?
It's very difficult because you're collecting a lot of imagery and you're trying to optimize how quickly you can process it. But before you can process it, you have to send the data somewhere. So there's a lot of technology in between to reduce the amount of bad imaging, right? And there's a lot of technology in the pipeline to pre-process, also tied to the battery power, right? So if we were able to do all the processing on board, it would be much faster. But that would use a ton of battery power. Right. So on the commercial side, everything is tied to battery power. And battery power is really hard to evolve if we don't have massive demand for more battery length. So until we have massive demand for people wanting to buy batteries that last longer, the technology companies that build batteries don't have no incentive for innovating in the space. It's too expensive. Right. The last time we had innovation in the battery space was in World War II.
Right. And this is the quadcopter space. So Adam, some of the stuff you've worked on has been fixed wing. What can you do with different form factors that really we haven't seen yet?
Yeah, so I think there's a lot you can do. And I think that drones have gotten popular over the last few years. And to most people, this is what a drone is. But it's basically like an RC quadcopter with a camera on it from a form factor standpoint. And I think that if you just sort of think about it from a first principle standpoint, I think we're a really long ways away from where you can end up if you really think from the ground up of I want something to fly for this long, it needs to fly this fast, I want it to be as quiet as possible. So the basic idea is adding lifting surfaces, things like wings. It becomes more challenging from a control standpoint to do that. And it's kind of like a tightly coupled hardware-software thing. But I think that that's something that is kind of underexplored right now, but I think is going to happen at some point, definitely over the next 5 years.
Why is it hard?
The basic, if you have an airplane, you know how to control that. If you have a quadcopter, you know how to control that. If you have something that's a hybrid of both, it's less obvious. Right. And you can end up in situations where you kind of get the worst of both worlds.
Right. Okay. Let's change pace. Regulation. Clearly, loads and loads of developments in the regulation space over the past year. Christian, you were one of the first companies to get FAA exemptions and permission to do various things. Can you talk us through what's changed over the last year and where do you see it going?
So when I started Skycatch, my biggest barrier was to get investors comfortable with the fact that this was going to work itself out. A lot of making up things, mixed up with, this is what I see, the policy evolving towards. We took a different approach early on. Rather than going out to Congress and try to hire lobbyists, we decided to go directly to the FAA and say, we want to become your partners. But because of the fact that they're a government entity, they weren't able to work with us at that level. So it required a lot of back and forth. And it wasn't until we actually started getting some real clients and that we were able to feed them information about how clients were using the data that helped them understand how to draft an exemption, perhaps. And I spent a lot of time with them, with our lawyers. We spent a lot of money on the legal side drafting some of the initial templates with them and on the phone, going back and forth. And a lot of the people using exemptions today are using our templates. And we decided to work with them rather than going against them, and that helped us move the needle forward. But we're not really focusing on the exemption program today. Instead, we're focusing on what really works for commercial institutions. In job sites today, we have more hazardous material and machines that are far more dangerous than this thing flying around. They already get permission to do all this, altitude permission. All of these things are already going through a process of getting certification and permission. We believe that a drone is just part of the equipment. So what we're proposing, and we've submitted comments to the policy, that we want a separation between job sites and everything else out there. So anyone who's using this as a tool versus anyone else who's out there experimenting or flying it for hobbyist purposes or to take photos. And I think that will help the commercial space evolve a lot faster. And I think that there's promising momentum on our end to get big companies involved in doing that. And I think there's some promise there.
Eric, how have you seen it from a DJI perspective, the change in the last year?
Well, I mean, on the commercial side, I think there's a lot of momentum. Again, sort of templatizing the process has been great. Also having blanket COAs, so authorization to fly as part of the exemption process now has helped a lot, under 200 feet. I still think that probably a very large number of exemption holders don't really know what it means and maybe don't fly in a way that complies with the exemption. One thing that is important to bring up is that there's federal permission to fly, but regional, domestic laws are right now the most interesting thing for us because it's there's a reactive bill-making process happening right now. If someone does something bad with a drone, the media writes, drone does this, but really the drone didn't do it, the operator did it. That would be like knife kills person, Nah, maybe not. But that's what happens, and then it results in a bill that says, okay, knife can no longer kill person, which is obvious, but in this case, drone can no longer fly or something. And so there's a lot of education that has to go on sort of at all levels, like from the city all the way up to the federal level. And some cities have done. Last year, we talked about a city that was giving a bounty if you shot a drone out of the sky. They wanted to do that, and didn't happen, luckily. So I think it's really complicated. I think we feel like it will solve itself. There's too much utility for these tools, and drones they're a generic platform. They're not a magic, it's like a car. You can use a car for a lot of purposes, including driving off the road if you'd like and hitting someone. But you don't do it, and because you're trained, there's insurance, all these things. So I think that's what we're dealing with in the industry, and the tech is just kind of flying in front of all of this, which makes it much more complicated.
And Dan, how are you getting your pilots, your contractors to conform with the regulations?
Yeah, and so I think there's some really good approaches up here, just in terms of how to think about this, how to approach this. I think a robust commercial sector is ultimately is the best arbiter of safe operations, because just in everyone's interest sitting up here, our livelihoods depend on safe, thoughtful operations, and so to encourage that, to get that out there is very helpful. I'd say at least I actually give the FAA a lot of credit for issuing what they called Part 107 to the NPRM. Essentially, this is a commercial drone operator's license. They released these rules kind of in February. They're not in code yet, but it is essentially going to allow someone for $200 to take a written test on some basic rules. And for every system under 55 pounds, which is the vast majority of systems, you have to fly within certain guidelines, under 500 feet, within line of sight, during the daytime. Some of those are problematic and sort of hampering the space, but if that in code would be a good starting point to allow people kind of like come into the light on this process. So I think in this case, honestly, like we're looking for the rule. Like we're looking for something concrete in place to harbor to, and that our team felt like that was a good start.
Okay, so final few minutes. There's obviously been a lot of focus by the media on the darker side of drones, but there's also been some brilliant examples of social good being done by drones. And maybe Dave, you can share. What are the exciting examples you've seen in the past year?
Anecdotes all the time. I don't remember the timing on it exactly, but there was a guy who was flying over some slaughterhouses and noting operations that were not complying with the rules for how they should be operating. There's great ecology examples, a scientist flying over jungles looking for, I think it's orangutan nests up in the trees and counting the number of nests and using that to estimate the population. So I think we actually have a new liaison at 3D Robotics for academia and researchers, and so he gets to talk to these people all day that are doing like population ecology with drones. And I think for me that's some of my favorite stuff, because it's gathering data that can help make changes that really there would be no way to do it before drones.
Christian?
I think that drones for good, dronies are no, just kidding. Selfies? No. I think we experimented with a relief effort a few months back where Nepal suffered a massive earthquake, and we sort of immediately emailed everyone in the team and said, if anyone wants to volunteer to go out there and maybe record some footage that could be helpful for anybody, let me know. Everybody replied back, and in a day, we had 3 people deploy out to Nepal, and we were there for about a month and a half. And the outcome of it wasn't necessarily what we were planning on doing initially, which was potentially find someone, rescue someone. The outcome was we ended up working with UNESCO and the World Bank. World Bank needed footage to find out how much money they were going to deploy into that location. We were able to expedite how quickly they got resources by this footage. We were able to work with the government because the government was shutting down everybody who's flying drones. We were the only company authorized to fly in Nepal at one point. And all of the data was used for figuring out how much money were they going to deploy into these different areas. UNESCO was using it to completely map all of these heritage sites and create 3D models of it so they can rebuild them from scratch. From that, we initiated another initiative where we created something where drone data is going to be useful now for creating snapshots of all heritage sites around the world. Not just with our drones, but they're going out there and trying to locate drone pilots to help them map all of these different types of heritage sites. So there's definitely incredible amounts of good from drones, and there's been all kinds of commercials and marketing around social drones for good, but we haven't really seen real drones for good in action. And I thought that was a good example that we were proud of.
That's great. So final question, I'll ask to Adam and then Eric.
Thank you.
We're here next year. A year from now, we're going to be on stage. What's going to have been the big development technically that's going to be changing these drones? What can we expect to see on stage? What are these going to be able to do?
I'd say Skydio system stopping them from running into stuff, but I'm biased. No, I think that autonomy is on the cusp of happening. I think that we have like the basics now, but if you just look at like the gap between what these systems do in the hands of an expert operator like Eric and what they do when they're under some computer control, that gap is enormous today, and I think that we're ready to close that pretty rapidly.
Eric?
Yeah, I agree. I think that automation in all sorts of systems in the air and in robotics in general, I think is already taking off, and we'll see that momentum continue. And then, I think what's going to happen is we're just going to see constant improvements in sort of every axis in drones. And so those are the sorts of things that make the technology improve exponentially, because you have exponential increase in multiple axes. And then also, I think there's this software economy we're talking about around drones. We haven't actually talked about it that much on stage, but I think drones are becoming platform. So I mean, we have an SDK out for ours. There are SDKs out for 3DR as well, and we're starting to see developers write apps across horizontal big slices of functionality, but also in vertical industries. And so what's going to be really interesting, I think, is what happens on the regulatory front with having to have operators behind each drone right now. Because that's not going to be necessary, I think, in a year, and in some cases isn't necessary now. That's part of the proposed rule. So, again, I think tech will continue to outpace our ability to regulate, so it's important that the rules are broad enough, I think, to cover everything that might happen, so we're not kind of hampered by them going forward.
Great. Okay, so now time for questions. First question, please.
Hi. Great talk. Very interesting. One of the questions that I had that just kind of kept running through my head, I did a little work down in the oil patch, and I know that they use drones for a lot of subsea stuff, pipeline inspections, ground analysis. Is any of that technology something that you're also looking to either steal from or move into? Because, I mean, we're all becoming, drones in the air are like the new thing, but really drones have been around for a long, long time in various forms. And where do you see that interface happening or changing and merging with what you're working on now?
Maybe Christian, do you want to take that?
Yeah, I think that you're absolutely right that, I think we're already going through that transformation where companies are maturing, and it's less about the drone itself. It's less about the server or the computer. It's more about the software and the data you get out of it. And they're even evolving beyond that, is once you get the data or you get it on a recurrent basis, have that created trends, or is that giving me more information that is able to inform my team to make better decisions, whether it's inspecting the terrain for specific spots, and that's also driving innovation on the sensor space as well. So you're absolutely right. As we evolve, it's going to be more about the intelligence and the data that we collect from the ground, and less about the actual unit.
Next question.
Hi, John Giddings with Santa Clara University, and I'm also an investor. My question is maybe for Dan and maybe for Christian. With a lot of new things that have come along, through history, the exciting thing that really was big was something that nobody expected. The original application wasn't. It was something different. I like with the records, Thomas Edison thought we would record presidential speeches and maybe some Shakespeare, and he was offended at recording popular music, just way off base. So, of course, it was 10 times, 100 times bigger than what we anticipated. What is that going to be with drones, or have we already seen that, or is that shoe yet to drop?
Adam, you're on the bleeding edge.
Yeah, I mean, I think that it's hard to say the shoe dropping. I think that there's going to be like a really exciting 5 or 10 years of the technology getting better and that opening up things that weren't possible or aren't possible today. Like the fundamental question posed by the platform is, like, what would you do just with a camera? Like, what would you do if you could place a camera anywhere in the world at any time you wanted without a person who needed to be there to control it? And I think that's it's a pretty profound thing, and it's hard to guess like where that's going to take you. But it's the kind of thing that has like a million different answers to a million different people. And a lot of them are hard technically now. I think a lot of those are going to become possible over the next 5 years. So I think it's hard to say exactly where that takes us, but I think it's going to be pretty exciting to see.
Christian?
Yeah, I think that, going through this process from the beginning was pretty tough because we didn't have that, massive demand for this new data set. we didn't have this massive demand for data intelligence. The market wasn't there yet. But once you have a market that's hungry for this data, once you have a market where they say, I can please my shareholders with 20% optimization, and there's tons of money going into this market, the amount of innovation is going to dramatically change. So you'll see a massive shift once you have massive maturity of the market.
Next question, please.
Glenn Speckert. Question for Eric. In relative to the discussion about image processing and battery and onboard in the cloud, the discussion leaves out the other part, which is your iPad or your mobile GPU. So everybody's got a GPU which can deal with it, and it seems like the right architecture is limited by capture, get to the GPU, make its decision, and get back to effect real time. My understanding is with the current generation of APIs, you can do that, and you can move the intelligence off the onboard computer as a question of response time. I mean, isn't that the architecture? Doesn't that make sense? Not cloud, not onboard.
Eric, that's
Yeah, I can talk about that. Our current set of SDKs, for example, are designed around points of interaction with the drone. So the one that's most mature is a mobile SDK, which is made for Android and iOS and can take advantage of the GPU. So the bottleneck is really getting data to and from the drone. It's not only about latency, but it's also about bandwidth. So Lightbridge, which is the protocol we use to communicate, is sort of 4 to 10 megabits per second. So we're getting HD, 720p HD video along with telemetry and control, and you can act on that locally as fast as you can, and then you can tell the drone what to do in response. But there are also onboard APIs, not on our consumer systems yet, but on our commercial systems that would then allow you to put anything you want on board, like a Linux computer or Raspberry Pi or something, and do the processing on board. So we've gone a little bit of a different direction. 3DR, you can talk about this, Dave, but you have onboard computation.
Right, yeah, so we put a little more computation on board. Fundamentally, you're right. When you're operating a drone, you're operating a distributed system. You've got the computer on the vehicle, you've got the computer in your hand, and then in the case of 3DR drones and DJI drones, you also have an iPad or an iPhone or an Android tablet sitting there too. And so if you want to move some of the decision making about flight paths to the tablet, it tends to come down to a problem with latency, because even if you can stream the video that the drone is seeing down to the tablet, if you are flying in a mode where you want it to be able to make decisions quickly, like dodge through trees, then you probably want to do that computation as close to the camera as possible, because even like a tenth of a second delay could make a difference in the drone's ability to see something and make a decision quickly.
You both, in the past year, certainly DJI and I think 3D Robotics, you've both moved control to, you've made the remote control itself more powerful, and the controls that used to exist on the device now are resident in the remote control. Eric, why is that?
From our point of view, it's really about convenient use of the camera, because the camera is certainly, right now in the consumer world, is the center of any given drone. And if you have to take your hands off the radio, again, this is related to manual piloting. Once you take your hands off, it's in a hover, it's in a position hold, and then you manipulate your camera somewhere. So we moved all of the controls to a place where you could access them without taking your hands off the sticks for manual flight. And we've also, and both of us have done this, added customizable buttons, because as the use cases increase for drones, people are using them for all sorts of things that we had imagined, and of course things that we hadn't imagined. They have different needs mostly for camera control, but also for aircraft control. So having these customizable buttons and just a couple buttons, dials, and it will actually create a lot of power, not only in the apps that we write, which right now are centered around camera use, but also for apps that are written by other people.
So it's actually the opposite. So there's less stuff happening on the mobile phone than there was last year.
Well, I think it's both. There's more stuff happening everywhere,
right?
And the apps are getting a lot more powerful.
Right. That's great.
And you'll just see more compute happening on every spot in the system.
Got it. Next question.
NASA Ames Research Center, David Murakami. My question is, what role do government and academic research institutions play in solving the questions that the big problems that you guys brought up? And also, what does the path look like from a discovery or an invention in a lab down to one of your products?
Adam, do you want to take that?
Yeah, so before Google X, I was in CSAIL, Computer Science and Artificial Intelligence Lab at MIT. I think one of the trends that we see is that, at least in robotics, and drones are kind of an outgrowth of this, I think that the most exciting stuff is kind of transitioning from happening in research labs to happening in companies. Like the academic research that has been ongoing, for the last 30 or 40 years in robotics has matured to the point where it's ready to actually work. And there's kind of this tipping point where academia is good at sort of one-off examples of what's possible. And sort of one person or one or two people working very focused on a particular problem. I think that we're reaching a point with drones where it's sort of a layer up from that now. The more interesting problems are the things that it takes a team of dedicated people with a clear use case going after. And it's a lot of the same underlying stuff, but it's a more focused and a more application-oriented approach. And our team at Skydio is reflective of that. A lot of us come from academic backgrounds, and we work with people who sort of have expertise in each of the key pieces that you need to put it together. But I think, to me, the analogy is similar to distributed systems. 15 years ago, if you wanted to do research in distributed systems, you'd go to Stanford, and now you'd go to Google, because there's nowhere in the world that you can do more interesting work than at Google if you care about huge data sets and lots of computers.
So we were just at NASA Ames not long ago for the UTM project, the traffic management project. So I think one of the great things is that you can bring industry together onto a neutral territory to talk about some of the issues that will require the whole industry to solve. One thing that did not come up at Ames, which is very interesting, is that because it's NASA and is publicly funded, DJI is a Chinese company, we cannot actually work directly on the UTM project, and we have to work through partners. So that's a very interesting situation, and I think I think it's going to have to change, especially since we have 70% of the market right now. So, to exclude 70% of the drones in the air from a UTM project is a little crazy.
Okay, next question.
Yes, my name is Thierry Doyen, and I was wondering if the definition of drones has shrunk upwards, I would call. Sounds like everybody's talking about aerial drones. Is any work being done on terrestrial or under-terrestrial or undersea drones? Anybody has comments?
There is. There's a company in Berkeley called OpenROV that is building underwater drones, and the same autopilot that runs our solo aerial drone can be used to drive terrestrial drones around. I think flying drones are kind of unique, though, in that they're getting so much more attention than any of the ground-based or even the underwater. And I think it's just because there's so much space up in the air that people want to explore and want to use that it's a easier problem to put things up in the air where there's not as many things around to run into, and there's a lot of things to observe up there.
Great. Next question.
Hi, I'm Jake. I'm a construction project manager, and I've been using DJI drone for about 9 months now, and it's been very, very useful. But my original inspiration for wanting to get one was I wanted to be in my office in front of a computer, have one take off, go look at something, because I was spending so much of my time driving across the valley if I have a project, up in the North Bay. Is that going to happen? Is that the right thing to hope for, or is it better to have a drone covering every square inch? And I'm just looking at the last time that site, was updated.
Maybe Dan and Christian, you can deal with that.
That sounds like a good dream. Certainly, I think if the person's doing 60 or 70% of the work now, you have to imagine in a year or two it'll be down to 40 or 30. So maybe if it's a drone pilot, it'll be a drone operator in 2 years, and maybe be largely a technician monitoring largely autonomous systems. And I mean, there are tools you can use to launch from your office and have it go fly. They're not all available publicly yet. But I think there are already some autonomous systems, and I think we talked a little bit about this, Dave, but just as much as people, it's really hard, like a person and a machine can do a lot together. It's so hard to just utterly remove the person from any interaction whatsoever, even if you're just maintaining or occasionally repairing a system. It's just hard to totally take the human out of the loop, even though that's kind of the inclination. So I share that with you, and yeah, it's an interesting take.
Christian?
Yeah, I think it is a very hard problem to solve, but I agree with you that the ideal sort of solution would be to completely remove the human factor of getting that data, because all you care about is not flying the unit, you care about the information you get from it. And that is clear with massive, big companies who are interested in moving all of this information into resulting in changing the speed in which they're able to do things. I think because we're going through a period of discovery and R&D, it's still very viable to fly these units manually. But we've seen demand from the market where they want to be able to deploy this extensively, where the data capture is so high that you couldn't possibly have 5 people flying at the same time. So it is definitely going to move in a direction where you're going to have these units completely fully autonomous. This is something where we are investing a lot of effort into, and we're planning on working with companies like DJI, 3D Robotics, to see if we can actually implement the same systems using our software, but using their hardware. It comes down to maturity of the market. As soon as we have that high demand of companies wanting to utilize that, it's just going to happen.
Great. Next question, please.
Yes, Vincent Pluvinage. I have a question about batteries. You have talked about the limitation on flight time and computing power on board. Now, assume that in 6 months you can have batteries the same volume and the same weight, but 50% more flight time. What is the impact on your commercial customers?
So, Adam, do you want to talk through the fundamentals of where we are with batteries? Are they improving that much?
I mean, that sounds aggressive, but I think this is more of like a battery hypothetical. I mean, the straight math is just like linear. Like if the battery gets 50% better, you can either make the drone 50% lighter or fly 50% longer. In terms of use case, I think that it depends on what you want to use it for. I think for people manually flying, 20 minutes tends to be a pretty long time. I think maybe Dan or Christian can comment more. I think a lot of the commercial stuff is limited, where if you could fly for an hour or 2 hours, that would be kind of transformative in the kinds of missions you could do.
Yeah, no, I think every minute in the air buys you time, buys you acreage, buys you data you can pull down. I mean, just if you can cover the vast majority of systems in one flight, then just it is like not the biggest problem in the world to stop mid-map and land and change your battery and go back up and continue mapping. But I think you're just buying value with every incremental second you can have in the air.
And how fast are batteries improving? I mean,
not much.
Not much. Sort of, it's in the 10% range per year. It's not. You're not seeing.
Yeah,
I mean, it's the outlier relative to all these other.
We've seen companies trying to innovate in the battery space, but they take all kinds of shortcuts when it comes to safety. So, and batteries can be very dangerous, especially the ones we use. So it's a tricky thing where you still need to rely on those big companies who make these batteries to invest. But so long as, I mean, if people are not buying battery, if they're not going to spend more money for batteries that last longer, they're not going to make them.
Right. Eric?
I think, 50% increase in battery power could translate to, for example, a Phantom that's 1.5 pounds instead of just over 3 pounds. And I think we're at a sort of a strange state right now in which even the minimum useful size is still annoying to people. You know, it's loud, it's 3.5 pounds, which seems like it might cause damage. But what if that were 1.5 pounds? And I think, we fly these little like 1 or 2 ounce quadcopters around that have cameras on them, and the cameras are horrible. But it's very easy to imagine that those cameras will be very good in a few years. And of course, they'll have small sensors and all sorts of problems you can't solve, but they could be useful. And if you do a roof inspection with a 1-ounce drone, who is going to disallow that? Probably nobody. So I think, the battery power question is really interesting because I would love to see things get smaller and lighter.
Right. One more question. So.
Hi, this is Pranav here from SAP Labs over here in Palo Alto. I think Christian mentioned something interesting, and also I think Dan. So, I come from the enterprise world, big data, cloud. So, specifically to Christian's example with Komatsu, where the drones are up in the air, they come down, and then you push the data once they're on the ground. So, leveraging today's cloud platform, today's big data computing trends, do you think that sending the data real time to the cloud, getting information processed to the drone while they're up in the air itself, could you do things more better? Do you have scenarios which you cannot do today? So just wanted to get your thoughts on real-time processing while the drone is up in the air.
Yeah, being able to get the data in real time can really, that would be ideal. Komatsu would be very happy with us. But it's nearly impossible with the technology you have today, unless you have a tether. But if you have a tether, you can really go and do the stuff that we do and cover an entire job site. So yeah, definitely a space where that kind of innovation will allow for other machines to move faster. Today, the bulldozer waits for us to process the data, but bulldozers can start any time. But it's waiting an hour, 2 hours, depending on how much ground we're covering. So ideally, bulldozer wouldn't be waiting. It would be actually doing the stuff in real time.
Great. John, you had a question.
Just a quick question. And I was thinking about a previous question that was asked about the kind of thing that would, have drones blanketing the skies. And we've been talking for an hour or so, and nobody's talked about Amazon delivering items to our house or Pizza Hut delivering pizza. How far away is that from ever being reality?
Battery power, too.
And battery power. We'll talk about that.
Everything, especially delivery, ties to anything meaningful when it comes to delivery has to be at least 50 pounds. If you want to carry 50 pounds, you have to put a massive battery in it. And if you want to fly for a longer period of time. So, everything is tied. Unless Amazon is investing massive amounts of dollars into battery innovation, I don't see this happening in the next 5 to 10 years. And I think that most people will agree with that. And unless they have a special technology project that is evolving, it's massively increasing the battery power. Until you're able to increase that or make it better, more, last longer, I don't see that evolving. And then all the other components that are tied to delivering something over people's heads, safety, landing in places, routes. I had chats with the two biggest, logistical companies that handle mail and delivery, right? And not having a clue about exactly what we would offer to them, they had already been thinking about this. And the reality is their biggest concerns are, being able to move things from one place to the other in the middle of Colombia because they get attacked all the time, or being able to move things from one place to the other, bypassing the BART from the Bay Bridge because it gets congested and sometimes they have to send people through it. There's specific use cases that are not just your last mile delivery that I think are going to be more interesting for these companies, and these companies are already hiring teams to solve it. So you should expect to see development or innovation with drones in those areas rather than last mile, I believe.
Karen.
I'd like to thank our speakers for sharing their insights and stories so candidly. And Robin, our masterful moderator, and this is your 5th moderating at the Churchill Club, and you're marvelous. Thank you. We do have a small token of our appreciation and esteem, and it is, of course, the Churchill Club speaker T-shirt.
Thank you so much.
If you come back next year, you just might get another one. A recording of this program will be available on our YouTube channel within a day or so. So we hope that you'll access that and spread the word, and you will find other recordings of other programs there. So we hope you find that to be a useful resource. Thank you again to Accenture, and you have been a terrific audience. Thank you so much. Be safe, and see you next time. Good night.